Now let's take a look at problem 1. For the function f of x equal to piecewise function here, we need to find out two limits. The first one is when x goes to 0, and the second one is when x goes to 3. So the first problem is actually very simple. To determine whether the limit exists or not, we just need to look at the limits from the left and the limits from the right. So now let's work on this question. So we're gonna first look at limit from the left, that is 0 minus f of x, right? And because the expression when x is less than 0, fx is equal to 2. So this gives you that on the left side, this is gonna equal to 2, okay? And we also need to look at the limit from the right side, that is 0 plus f of x. Right. Now we're gonna take a look at the second expression here. It says when x is greater than 0 and less than 3, you're gonna use this expression. Okay, so on the right side of 0, we are gonna use this expression, which is x squared minus 2. Now we can now plug in 0 into this expression, so we have 0 squared minus 2, which is negative 2. Right? So we now see that the limit from the left side is 2, while the limit from the right side is negative 2. And this is not equal. And therefore we can conclude that limit x approaches 0 does not exist, because the left limit is not equal to the right limit. The limit exists only when the left limit is equal to the right limit. So we basically just checking these two numbers. If they're equal, then the limit is that number exists, otherwise it does not exist. Now let's take a look at problem B. Part B here, limit x approaches 3. So we're gonna do the limit from the left and the limit from the right. From the left side, that is 3 minus f of x. And we're gonna use the second expression here because on the left side of 3, that means x is less than 3. So we're gonna now use this 3 minus x squared minus 2. Now as before, we plug in the number, so we have 3 squared minus 2, which is 7. Okay, and that is our left limit. And we're gonna look at the right limit. Okay, and we're gonna use this expression 3 plus, that means x is greater than 3. So we're taking this expression right now, and it says f of x is equal to 7. So it's gonna be 3 plus just 7, right? So it's 7. Now we check these two limits. Limit from the left is equal to the limit from the right, and therefore we can conclude that the limit exists, and the value of the limit is 7. So very simple, you check the limits on both sides. That is how we solve the problem 1. Now let's take a look at problem 2. We have a bunch of different types of limit to solve here. So the first type, I would say there are some 0 factors for you to cancel out. That is from question A to question D. They are all of the same type. So for this type of limit, you see that when you plug in the number, into the numerator as well as the denominator, you always get this kind of form, 0 over 0. Okay, so this is 0 over 0 type, this limit. So you will need to do something to this expression so that you can get rid of the 0 factor and you no longer have the form 0 over 0. And after that, you can plug in the number x into the expression. That is the general idea of solving this type of limits. So let's see how we can solve them. For the first one here, we need to apply factorization. So for the top, you're gonna use this formula, that is a squared minus b squared equal to a minus b times a plus b. This is called the difference of square formula. Now we can view this x squared minus 9 as a difference of square. So 9 is equal to 3 squared, right? So we have x squared minus 3 squared, and then we're gonna apply the formula above. So we have x minus 3, x plus 3. That is the factorization for the top. And for the bottom expression, x squared plus x minus 6, we can factor it out as x plus 3, x minus 2. You just think of two numbers whose product is -6 and whose sum is +1. The coefficients in middle term here, that is 1 here. Okay? And this is 6, -6. So now we can factor the top and the bottom for this expression, and it's equal to x minus 3, x plus 3, right? We just replace x squared minus 9 with this factorization, and we replace the bottom with x plus 3, x minus 2. Now we can see that x plus 3 is on the top as well as in the bottom, so we can cancel them out. And now we are left with x minus 3, x minus 2. But now we don't have the 0 factors anymore. We've get rid of it. And now we can plug in -3. So we have -3 minus 3 divided by -3 minus 2. That is -6 divided by -5, which is 6 over 5. It's no longer 0 over 0. Okay, that is the method. Now let's take a look at question B. Question B, there is a square root here. So for this type of question, you're gonna multiply something called the conjugate. What is the conjugate of this expression? Well, you just need to turn the sign in between to the opposite sign. So that is x plus square plus 6. This is the conjugate of this expression. This is the conjugate of x squared minus 6, x square root minus 6. And we can also say that square root of x minus 6 is the conjugate of Now let's take a look at the question B here. For this type of question, you will need to multiply something called the conjugate. So whenever you see this kind of square root expression, you will need to create the square root formula, the difference of square formula, so that the square will cancel with the square root. So for this expression, square root of x minus 6, if we can multiply this with square root of x plus 6, then we can apply the previous formula a minus b times a plus b, which will give us the a squared minus b squared. And the a squared, the square, will cancel with the square root. And this thing that we're multiplying with, x square root of plus 6, is called the conjugate of square root of x minus 6. So this type of question, you're going to multiply with the conjugate, multiply with square root of x plus 6 here. Just keep in mind that when you multiply this to the top, you need to multiply the same thing to the bottom as well to keep the expression the same. So now we have limit x goes to 36, and the top expression has become square root of 6 squared minus 6 squared by the difference of square formula, right? And the bottom, we don't need to change it. So it's x minus 36, x square root of x plus 6. And now we compute the top. So we have x squared minus 36, x squared, x minus 36. Oh, no, not x squared, just x minus 36. This is square root of x plus 6. And now we see that both the top and the bottom has the expression x minus 36, which will cancel. And now we are left with 1 on the top and this in the bottom. Now we plug in, so we have 1 over square root of 36 plus 6, which is 1 over 6 plus 6, that is 1 over 12. Okay. Now let's take a look at question C here. We need to multiply this with the conjugate, which in this case is 4x plus 1 plus 3. Same technique as before. And now we compute the top by using the difference of square formula. So that comes to 4x plus 1 square root square minus 3 square divided by the bottom. We don't need to change anything for now. And I simplify the top. So I have 4x plus 1 minus 9, because the square cancel with the square root. And in my bottom, I just keep the same thing here. I simplify the top further. So 4x minus 8 divided by x minus 2. And we observe that we can rewrite this as 4x minus 2, right? I can factor out the 4, so the top expression can be written as this expression here. And now we see that both the top and the bottom has the same expression, s minus 2. will we cancel. Now we can have just the 4 on the top, and in the bottom that is for x plus 1 plus 3. We can just cancel out the 0 factor, right? And plug in. So 4 divided by 4 times 2 plus 1 square root plus 3, which is 4 divided by 8 plus 1. That is 4 divided by 3 plus 3, which is 4 over 6, right? Which is 2 over 3. Okay? So the question C is the same as question B. We need to multiply something called the conjugate, which is the grid circle here, in order to create the difference of square formula to get rid of the square root. And after you cancel that square root, you can see what that 0 factor is. In this case, it's x minus 2. And after canceling them out, you can plug in as before to obtain the answer. That is question C. Now let's take a look at question D. It should be the same thing. Multiply the conjugate, but this time the conjugate is in the bottom, which is 1 minus 3x square root plus 1. Okay. Now we compute this. We don't need to change anything for the top for now. In the bottom, we apply the difference of square formula. So we have 1 minus 3x square root, bracket square, minus 1 square. And we now just keep the top here and simplify the bottom. So that is 1 minus 3x minus 1. Okay? And then simplify further. Now we have this one, right? Open the bracket. This one is cancelled with this one here. And we're left with negative 3x in the bottom. And we can see that both the top and the bottom has this x here. So cancel them out. Now we are left with 1 minus 3x plus 1 divided by negative 3, right? Since the 0 factor is gone, now we can plug in 0 to have 1 minus 0 plus 1 divided by negative 3, which is 1 plus 1 divided by negative 3. That is 2 over negative 3. Okay, so same type of question. Multiply the conjugate and get rid of the square root and cancel the 0 factors and plug in. Same step. Okay, very simple. And now for question E, F, G, these are the same type. It's called the you have the 0 in your denominator, but a finite number on top. So it's a non-zero over 0 type. This type. So for this type of limit, we only have 3 types of answer. The first one is positive infinity. Second one is negative infinity. And the third one is does not exist. For this type of limit, when you plug in, you always have non-zero from the top. For example, this one is negative 4, right? Non-zero. And this one, when you plug in 3, you have 6 plus 1, which is 7, not 0. For this one is apparently not 0. But in the bottom, you always have 0. So for example, this one, negative 2 plus 2 is 0. 3 minus 3 squared is 0. There's 4, plug in 4, right? 4 minus 4 is 0. So this is called the non-zero over 0 type. We only have 3 possibilities. Positive infinity, negative infinity, and does not exist. And it's very easy to understand the type does not exist. If you look back to the question 1 here, when the left limit is not equal to the right limit, then the limit does not exist. When the left limit is equal to the right limit, it's either positive infinity or negative infinity. So we will take a look at them one by one. So firstly, we're gonna look at the limit from the left. That is limit as approaches negative 2 from the left. So it's minus here, negative 4 divided by x plus 2 minus, right? So what does it mean by x2 minus? We're gonna draw the number line, right? Negative 2 is here. And then your x is from the left, so it's here, right? And x is approaching 2, so it's approaching negative 2 from this direction. So you see that x is less than negative 2, right? X is less than negative 2. And then we're gonna plus 2 on both sides, right? Plus 2 on both sides. So plus 2 on this side, plus 2 on this side, which gives us that x plus 2 is less than 0. Okay? So the denominator, it's approaching 0, but it's less than 0. So you can imagine in your denominator, you're going to have a very, very small negative number. And when the denominator is very small, the fraction is very large. Okay? So you're going to have negative 4 divided by just a notation here, 0 minus, which means it's a very small negative number, right? So speaking of the sign, the top is negative and the bottom is negative, so the overall sign is positive because this two negative signs cancel out. So we have positive, right? And as I said, when the denominator gets very small, the fraction is very large, so it goes to infinity. Okay, so that is how we solve this problem just for the left limit. And for the right limit, we do it the same way, right? I should not include this equal sign here. So this is the left limit. Right limit, x approaches negative 2 from the right side. That is plus negative 4 divided by x plus 2. And now we take a look at the number line. This time, your x is on the right side here, right? And it approaches negative 2 in this direction. So we have that x is greater than negative 2. And now we plus 2 on both sides. So we have x plus 2 greater than negative 2 plus 2, which gives us that x plus 2 is greater than 0. Okay? So it means the denominator is greater than 0 for this time. So we have negative 4 divided by 0 plus, which is a very, very small positive number. So speaking of the sign, the top is negative, the bottom is positive, so the overall sign is negative. And as I said, when the denominator is very small, when it approaches 0, the overall fraction becomes very large. So it's infinity. Okay, so the answer is now negative infinity. And by our previous discussion, if the limit on the left side it's not the same as the limit on the right side, right? These two things are not equal. And the limit will be does not exist. So the limit here does not exist. Same reason as the first question. Okay, very simple. So question E, limit does not exist. Now let's take a look at the question F. We're gonna take a look at the limit on both sides. Limit x approaches 3 plus, maybe 3 minus first of this, right? Square. So we draw our number line here. This is our 3, and x is now here on the left side. Approaches 3. So we have x is less than 3. Okay? And we minus 3 on both sides. So we have x minus 3 less than 3 minus 3, which gives us that x minus 3 is less than 0. Okay? X minus 3 is less than 0, but in our denominator we have this thing square. It's just not just only x minus 3. So when we square this thing, it will become positive. Right? Imagine -1 times -1, right, is greater than 0, while -1 itself is less than 0. So when you square something, it becomes positive. Right? So now it's equal to plug in -3 minus to the top. We have 6 plus 1 divided by 0. This time is plus. And we have 7 divided by a very small positive number, which is positive overall. So the answer is positive infinity. Okay, that is the left limit. And for the right limit, we do it the same way. 3 is here. Now x is on the right side. Approaches 3, right? So we have x greater than 3. And we minus 3 on both sides, which gives us that x minus 3 is greater than 0. And when we square it, it's also greater than 0, right? So we have now, this is 6 plus 1 divided by 0 plus, same answer as the left limit. So they're both positive infinity, right? When the left limit is equal to the right limit, the limit exists, and it's the same limit, so positive infinity. That is the answer of question F by discussing the left limit and right limit. Okay, so now let's take a look at the last one here, question G. Gonna do it the same way. Look at the left limit and the right limit. Left limit first. 4 minus 3 divided by 4 minus x to the 3. Okay, number line here. We have our 4 here. X now is on the left side. Approaches 4, right? So we have our x. It's less than 4. Right? And to obtain the expression 4 minus x, we're gonna multiply this inequality by -1 on both sides. So you can imagine you switch the 4 and x, so you have -x greater than -4. By multiplying -1 on both sides, you need to change the direction of the inequality when you multiply the inequality with a negative number, right? So the direction has changed, and now we plus 4 on both sides. So plus 4 on this side and plus 4 on this side. Okay, so we now have 4 minus x is greater than -4 plus 4, which gives us that 4 minus x is greater than 0. Okay, 4 minus x is greater than 0. So now our answer is 3 divided by 0 plus, which is positive infinity for the left limit. And for our right limit, do it the same way. 3 divided by 4 minus x to the 3. Okay, number line 4 here. X is here. On the right side, approaches 4. And now we have x greater than 4 because it's on the right side. And to multiply -1 on both sides, we need to switch the direction of the inequality. So we have -x less than -4. And now we plus 4 on both sides, plus 4 on this side, plus 4 on this side. And we have 4 minus x less than -4 plus 4, which gives us that 4 minus x, it's less than 0. Okay, so now 4 minus x is less than 0, gives us that the bottom now is less than 0. 3 divided by 0 minus, right, which gives us negative infinity. And I also want to emphasize that I said that the bottom is negative because the 4 minus x to the 3 has the same sign as the 4 minus x. I need to include the steps also for completeness. So to write one more step, as before here, 4 minus x. If 4 minus x is greater than 0, then the same thing happens to 4 minus x to 3. Because when you take the cube, it has the same sign as the original expression. The cube of a negative number is still negative. The cube of a positive number is positive. Okay. So include this step. So now we have the left limit at positive infinity, while the right limit is negative infinity. And we see that they're not equal. So the overall limit does not exist. Okay, for this reason. So that is our question G. Now, a summary for these 3 questions, you see that we do that in the exact same way by looking at the left limit and the right limit. If they are the same, then the limit exists is either positive infinity or negative infinity. Well, when the limit, left limit does not equal to the right limit, then the limit does not exist. So it's also a simple type of question. And the difficulty is how to draw the number line. That's kind of tedious. But we should keep in mind that even though you don't know how to do it, you should know that the answer is either positive infinity or negative infinity, or does not exist. It's always one of these 3 situations. So that is the second type of limit here. Now let's look at the third type. That is when x approaches infinity. So I will, for my opinion, this type of question is the probably the easiest. So the method is to look at the highest power in your denominator and always divide the top and the bottom by the highest power in the denominator. So for example, the highest power in the denominator is x to the 3. So you're gonna divide the top and the bottom by the same power. So let's see how to do it. I divide the top and the bottom by x to the 3. Okay, so I can turn my top expression into 1 plus 2 divided by x to the 2 plus 5 minus 5 divided by x to the 3 divided by just 3, right, plus 2 divided by x to the 3. Okay, so now I focus on my constant term here. Is 1, this is 3. And the rest of the terms, they all go to 0 because they have x squared or x cubed in the denominator. And since we have the condition that x is approaching infinity, so our denominator will get larger and larger. When the denominator gets very, very large, the fraction will become very, very small, and it's getting closer and closer to 0 as the denominator gets larger and larger. So they have x in the denominator, they all go to 0. So when we kind of plug in the infinity, we are left with 1 on the top and the rest of the term being 0. And same thing for the bottom, we only have 3 left, and the rest of the term becomes 0. So the answer is 1/3. Okay. So maybe you have noticed that the trick here is just to divide the top and the bottom by the highest power. And if the top and the bottom have the same power, then the answer is always the ratio of the leading coefficient. The leading coefficient for the top is 1, right? And the leading coefficient for the bottom here is 3, right? So it's just 1/3, provided that the top and the bottom has the same highest power. Now let's take a look at the second question. The second question, the highest power on the top is 4, while the highest power in the bottom is 2. So the highest power on the top is even higher than the highest power in the bottom. So you should expect that when you divide the top and the bottom by the highest power in the denominator, x squared, you won't get the same kind of ratio. So let's see how do we do it. Divide the top and the bottom by the same power, that is the highest power in the denominator. Now let's see what we get here. We have x squared minus x, right, minus 3 divided by x, and our denominator becomes, this is square, not 3, becomes 7 plus 9 divided by x squared. Now let's see. So because x goes to infinity, we have these guys going to 0 because of the same reason, and our only non-zero term in the denominator is 7 here, right? So we will have 7 in our denominator, and for the other thing, x squared minus x, it's a polynomial having the positive term, having the positive leading coefficient. So this thing, we know that it goes to infinity as x goes to infinity, right? If you look at the graph of this thing, it's something like this. This 0, this is 1, right? This is the graph of y squared minus x. As x goes to infinity, y is also going to infinity. So we have the orange expression here being infinity, green expression being 0, right? 7 is here, so it's infinity. Okay, so that is when the highest power in the numerator is higher than the highest power in the denominator. The answer is infinity. Sometimes we may get negative infinity. That is when the leading coefficient of the top expression is negative. So suppose in this question that we had negative sign in here, then the answer will be negative infinity. Right. But we have positive sign, so this is not the case. Okay, so that is question I. Now the last question, question J. we do it the same way. Divide the top and the bottom by the highest power in the denominator. The highest power in the denominator is apparently x, so we're dividing this by x, dividing this by x. Okay, so now we have x goes to negative infinity. So we're gonna let this x go into the square root. That is our goal, right? But keep in mind that we can't let something negative to go into the square root. For example, if you have a negative 2 times square root of maybe 2, right? So you can't just let the negative sign go into it. What you can let go is something that is positive, right? So you can only let this 2 go into it and leave the negative sign in the outside. So the 2 becomes 2 squared when it goes into the square root, and multiply with the 2 inside it, so it becomes negative 6 square root of 8. You always need to leave the negative sign outside of the square root. And in this case, since x goes to infinity, so x itself, it's already a negative number. So the negative sign is already hidden in this symbol x itself. You can't just let the x go into the square root. So that's the thing we need to pay attention to. Okay, so now what we do is to isolate that negative sign. So we change this expression, and it becomes 1 over x. I can write because dividing by x is essentially multiplying with its reciprocal, that is 1 over x. So we write this as 1 over x, multiply with this first, 3x squared plus 6. Okay, and for the bottom we can just do the same thing, just change the multiplication, change the division into multiplication. 5 minus 2x. And as before, we can distribute this into the denominator since it does not hurt us. So we have 5 divided by x minus 2 in our denominator. And for the top, we're gonna isolate that negative x, a negative sign. So we will write this as negative of 1 over negative x by placing double negative sign here. The reason we do this is because we want to guarantee that the expression we're working on, we're moving into the negative sign. The blue square here, it's a positive number. That is very easy to imagine. When x is negative, then the opposite of x, negative x, will be a positive number. So this thing, it's a positive number. Right? This blue box here is greater than 0. As long as it's greater than 0, we are allowed to move that into our square root. So we have this negative sign left outside of the square root, and inside our square root we have this thing, bracket square. Right? When it goes into the square root, we have to square it. That's the rule, right? And this multiply with the original 3x squared plus 6 divided by 5 divided by x minus 2. Now we simplify. the top expression, and we have negative. The top expression just becomes, 1 over x squared multiplied with 3x squared plus 6. And now we can multiply them through to have that 3, right, plus 6 divided by x squared. Right. Now we can kind of plug in negative infinity. We have noticed that when we have x in our denominator and x is going to negative infinity or positive infinity, these fractions are all going to 0. Okay, so when we plug in, we no longer see them. So we have now 3 plus 0 in our numerator and 0 minus 2 in our denominator. So the final answer is negative square root of 3 divided by negative 2, which is positive square root of 3 divided by 2. Okay, so the last question here is a bit technical, but it's the same idea. Divide the top and the bottom by the highest power in our denominator. The technical stuff here is how can we let the thing go into the square root. Before we do that, we have to guarantee that that thing is a positive. And in this case, since x is going to negative infinity, we have to isolate that negative sign to put an extra negative sign here, and the thing we're actually working on is 1 over negative x. When we put that into the square root, we have to square it, and that is the only technical stuff we need to pay attention to. So if in this situation x were going to positive infinity, we won't need to worry about that. We can just let x go into the square root without doing all sort of these complicated things. That is a lot easier. But since x is going to negative infinity, this will be different. We need to just pay attention to the thing that we're gonna put into the square root. So that is the only difference for x going to positive infinity or negative infinity for this square root case. So that is our question J.